There are three really important tools that we have in this section, and the only three tools that we have are the ones that we have to work with. So we have the power rule, which says that if I take the derivative of anything of this form, which sometimes to say that I'm taking the derivative of this, what I write is this right here. This can be read as d dx, or sometimes it just is read as the derivative of this thing right here. To take the derivative, I drop the exponent out in front and multiply by the coefficient of x, and then I reduce the power by 1. Then I also have the tool of the constant rule, and the constant rule says the derivative of any constant value is equal to 0. So if you remember, the rate of change of a constant function is a straight horizontal line, and that has a 0 slope, and the derivative tells us the instantaneous slope, but in this case it's always 0. Then finally, oh, and by the way, as you see here, we're using the x in the denominator. That specifies what our input variable is. Okay, so if you were dealing with t's, you would do d dt to indicate you're taking the derivative of some expression. And then finally, we observe the sum or difference rule, which is not really that important to state. We can observe a pattern in these things, in that if you take the derivative of a sum of functions, like let's say ax or 9x squared plus 10x, then you can actually take the derivative of each one of these individually. So I can take the derivative of 9x squared, and I can add that to the derivative of 10x. And the way I do that is by the power rule. Okay, so for example, in letter A, f prime of x says, okay, well, I have 2x to the first, so what I'm going to do is I'm going to take that power of 1, multiply it out front, which isn't going to change the 2, but I'm going to subtract 1, and then according to the sum difference rule, I can also take the derivative of a constant, which is, in this case, 0, so I'll have minus 0. And simplifying that out gives 2x to the 0, which is basically just the constant 2. And that should be pretty obvious because we have a linear function and has a constant rate of change. Letter B, we have f of x equals 3x squared minus 7x plus 2. Okay, so to find the derivative, we go term by term, which is another way of thinking about what the sum difference rule is. We go term by term. This is going to be bring down the 2, subtract 1, so we get 6x to the first power. 2 times 3 is 6. Subtract 1 from the exponent. Minus, there's a power of 1 here, so we bring that down out front. Doesn't change the fact that this is still minus 7, but now I have x to the 1 minus 1, which is the 0 power, plus the derivative of a constant is 0. And now as I simplify, I get 6x minus 7, because x to the 0 is 1, so we don't really need to write that. In letter C, we have f of x equals negative 1 over x squared. Okay, important property here that we need to remember from our early algebra days. So property of exponents that will help us make this problem easier, because this doesn't look like a power function to me. This is not of the form ax to the b power. My x is in the denominator, and it's all kind of goofy looking. So recall that if you have a negative exponent, like 2 to the negative 2, easy way to think about this is you put it over 1. To make it a positive exponent, by definition, this means 1 over 2 squared. So you can flip the numerator denominator, and you can change the sign from a negative to a positive, which gives you 1 over 4. Okay, so in this case we can do the same thing. We have a negative 1 over x squared. So we can flip the fraction, x squared over negative 1, except in order to be able to do this, I have to make the sign negative to indicate that it came from the denominator. And so that simply means, well, anything divided by negative 1 is just negative x to the negative second. And that's a pretty easy derivative to take. We have f of x equals negative x to the negative second. So I bring down the negative 2. So f prime of x would be negative 2 times negative 1, because that's the coefficient on the x here. I'm going to subtract 1 from the exponent. Now here's where you have to be careful, because the exponent is already negative. Negative 2 minus 1 makes it more negative. It makes it a negative 3. So you have to be careful with those negative exponents just to make sure you don't make this negative 1, because you're going the wrong direction. So negative 2 times negative 1 is positive 2, x to the negative third, and that's it. We're done. So letter D, we have the cube root of x. So D is f of x equals the cube root of x. Now, roots are really just ways of talking about exponents. So I always like to put an exponent on the thing inside the parentheses, which is x to the first, and then indicate what the radical is. Well, this is a radical 3, so that can be rewritten as x to the 1 over 3. And so you can kind of see where these numbers are coming from. I'm going to change my color here. And so the 3 is this guy here, the 1 is this guy here, and that allows me to basically express it in fractional form. So there's no magic going on there. This is just really what a radical means. It's a fractional power. And it says what times itself 3 times will give me this quantity here, which is a variable. So, well, x to the third times x to the third times x to the 1/3 gives me exactly x. Okay, so the derivative of this is found exactly the same way. Bring down the 1/3. Subtract 1 from the exponent. So I have 1/3 x to the 1/3 minus 1. And be careful here, because 1/3 minus 1 is negative 2/3. And if you need a little bit of a refresher there, we always can write a whole number as a fraction. Well, 1 is really just 3 over 3. And that gives me a common denominator. 1 minus 3 is negative 2, and it's negative 2/3. So there's my answer. And finally, we have E, which is f of x equals 1 over the square root of x. So this one kind of combines it. F of x equals 1 over the square root of x. So we're going to handle one thing at a time. The first thing I think I'd like to do is take care of the radical. So I will say, okay, well, this is a second root, x to the first power, so that must mean that I have 1 over x to the 1/2 power. So I have x to the 1/2 power, and now I don't want it in the denominator. I want it of the form something times x to the something power. And so now here's where I can flip this using my property of exponents, put it over 1, but change the sign on the power. So basically, we're taking the derivative of x to the negative 1/2. So therefore, f prime of x would say, bring down the negative 1/2, take the negative 1/2 in the exponent, subtract 1, and if you write 1 as 2 over 2, you can see that we get negative 3/2 as an exponent, x to the negative 3/2, and there's our final answer.